Welcome to my live streaming. So here I am again. I'm gonna discuss about electric force between electrons and protons in relation to the quantum mechanics, in the study of the motion, the behavior, and the interaction of light, matter, and energy in microscopic and macroscopic point of view. Macroscopic point of view meaning atomic particles, and then microscopic point of view in a micro level, right? Macroscopic and micro level. Microscopic meaning subatomic particles, something like that. Okay, so we need to recall also the idea of centripetal force, like that, and it goes back to the theory of Niels Bohr regarding the orbitals, okay, the orbitals of the nucleus, something like that. And then we need to study also the Heisenberg theory of uncertainty. Okay, we need to study also the Boltzmann law, and then the Boltzmann right, and we need to study also the Planck's law. Okay, but before going to that, we need to discuss the various constants. Okay, then we need to memorize the constants first. So first we need to memorize is the Avogadro number. Okay, so I have to write again. For a while. Constants like this. Oh, I have no pen to open it. Okay. Constants. First, the Avogadro number. Okay, number one. Avogadro number. Avogadro number is equal to this one. Okay. So the value will be 6.023 times 10 to the 23 per mole. This one. Okay, guys, like that. Okay, so number two, we have the universal gas constant, and the abbreviation of Avogadro number is NA, like this. Okay, universal gas constant. Okay, universal gas constant, capital R, or this is just equal to gas constant. It can be used in ideal gas law, right? In the equation PV and RT, pressure times volume times the number of moles times the universal gas constant R times the capital T Kelvin, something like that. So this is universal gas constant in solving gases related problems. Okay, something like that. So we have 8.3145 joules per mole Kelvin. Okay. Okay. And we have also an 0.08205 liters atmosphere mole Kelvin. Okay, 0.08205 electron atmosphere mole Kelvin. But you can also use other values of R by using the ideal gas law equation, and let's assume that to be an ideal gas. 1 mole of an ideal gas will occupy 22.414 liters of volume of gas at standard temperature and pressure. Meaning to say, pressure is 1 atmosphere, and temperature will be 298 degrees Kelvin, something like that. Okay, then we can compute for the R for that, any kinds of R, but for the purpose of faster problem solving, we need to memorize only 2. Okay. Okay. Number 3, Boltzmann constant. Okay, the contribution of Ludwig Boltzmann is all about the the entropy of a microstates in a molecules, that it should have an increasing entropy, the randomness of those molecules, something like that. Okay, so we have Boltzmann constant Kb, okay, like this, Kb, like this, Boltzmann constant Kb. Okay, Boltzmann constant. Okay, so the Kb will be equal to R over Na. Okay, the Kb will be equal to R over Na, in which we have the value of R here divided by the Na will be equal our Kb. So we put the R, which is 8.3145 in the numerator, and the Na will be 6.02 times 10 to the 23. We can get an answer which is equal to 1.38 times 10 to the negative 24 joules per Kelvin, something like that. Okay, so this is now our Boltzmann constant, 1.38 times 10 to the negative 24 joules per Kelvin. So since that is the Boltzmann constant, it is really confirmed that he is really discovering the entropy, because the unit of entropy, guys, is joules per Kelvin, meaning the heat over the temperature. Okay, so heat is an energy expressed in joules, okay, and over the temperature expressed in Kelvin. So meaning to say, this constant is from Boltzmann, Ludwig Boltzmann. Okay, the discovery of entropy in a microstate. Okay, we have also the Planck's constant H. Okay, for Planck's constant H is equal to 6.67 times 10 to the negative 34. Okay, joules per second, like this. Okay, so our Planck constant is 6.67 times 10 to the negative 34. Okay, the other one is negative 24, the Boltzmann constant. Just a difference of exponent, negative 10, right? Like that. Okay, and then it's negative 24. So joules second. Okay. Number 5, we have the Faraday constant. Okay, the Faraday constant, which is equal to okay, which is equal to the okay 96,485 coulomb per mole electron. So this is the Faraday constant, 96,485 coulomb per mole, okay, electron. Okay, number 6. We have the Coulomb's constant. Okay. Oh my gosh, what's this? Wait for a while. 14344. Okay. The Coulomb. Hi, I'm Michelle. Thanks for watching. The Coulomb constant number 6. Coulomb constant. Okay. The Coulomb constant will be equal to 8.99 times 10 to the 9 Newton meter squared second. Okay, this one, the Coulomb constant is 8.99 times 10 to the 9. Okay, Newton meter squared c squared. It is Coulomb's constant. Okay, and then electric charge constant number 7. Electric charge constant is equals to 1.602 times 10 to negative 19 coulomb. Electric charge constant 1.602 times 10 to the negative 19 coulomb, meaning to say 1 electric charge is equals to this value. So we will use the value of current, okay, is equal to the charge, electric charge over the time. Okay, like that. So that is coulomb per second. Meaning to say 1 ampere is equals to 1 coulomb per second. Okay, like that. Okay, and 1 amp per second is equals to 1 coulomb, something like that. Okay, and now number 8, we need to get the Newton's gravitational force constant. Newton's gravitational constant, represented as capital G. Okay, like this. Newton's gravitational constant. This is not the acceleration due to gravity constant, This is different. This is applicable in the universe or the planetary motion regarding the relativity theory or relativity of Albert Einstein discovery, something like that. Okay, in the planetary orbit application, planets to planets, like that, meteors, asteroids, comets, the stars. If we try to measure the force and the magnitude with corresponding distances among each other, for example, Venus, how many distance apart from Earth, from Saturn, then we will use this constant, the Newton's gravitational constant with capital G. This will be used there, okay, in the computation of the force and the magnitude in going to the orbit, right? Something, each planet will revolve on the orbit, and they will also rotate like this while revolving, so they have their own spin, positive and negative spin. Ganon. Okay, planetary science, right? Okay, so our G is equal to, okay, 6.7 times 10 to the negative 11 Newton meter squared kilogram squared, like this. 6.7 times 10 to the negative 11 in Newton meter squared. Okay, kilogram squared. Okay. Now we need to determine also the Bohr radius of the, like this in the Bohr model. We have the orbital 1, orbital 2, orbital 3, or energy level 1, 2, 3, and we need to determine the radius, something like that. Okay, so we have the Bohr radius constant. Charot. Okay, number 9, Bohr radius constant. Actually, you can compute this by using the equation of the centripetal force equal to the electric force of electrons and protons equation. Oh. Bohr radius equals to kaloka 5.11. Okay, 5.11, something like that. Or shall we say 5.82 something? Okay, so let's say 5.6, 5.8, something like that, times 10 to the negative 11. Let's say 5.8 lang siya. Okay, then this is matter. Okay, 5.8, around. Bohr radius is around, it could be 5.6, 5.7, 5.8, something like that. Okay, or it could be times 10 to the negative 11 meter. Okay, ganon. After that also, we can determine the momentum. Okay, momentum is the mass times the velocity. Again, if you try to compute the momentum using the centripetal force formula, okay, in the Bohr model, right? The nucleus, orbital, something like that, we can obtain the velocity, the momentum. Momentum is P, represented as P. So momentum will be equal to 2.810, something like that, 2.810. But I think I could have memorized already, but as that is 2.810 times 10 to the 6, like this, okay, meter per second. And this is the velocity, sorry, this is still the velocity, not the momentum. Okay, velocity of an electron. Wow. Velocity of an electron, because we are referring here electrons in quantum mechanics. Okay, so 2.18 times 10 to the 6 meter per second. This is the velocity. But don't worry, we can still compute this even though we will not memorize this and this radius. Okay, but the other constant should be memorized really. Okay, what else? So we have the Planck constant. Okay, blah blah blah, chuba chuchu. Okay, ganun siya. So there are 10 constants will be used over and over again in quantum mechanics. Okay, now I will introduce you the formula. For example, if the problem will say calculate the force field, something like that, or calculate the electric force between two electrons with 5 meters apart, okay, or between two protons 8 meters apart. So the clue there, we will be using the formula of the centripetal force and the electric force equation. I will show you. Okay, it's gonna be like that always, so constant, since we know. But before that, I will still also acknowledge, wow, acknowledge the mass of an electron. Okay, because the mass of an electron is constant somewhere along the way, and then you need to adjust that one, because for example, if your fluorescent light or bumbilya or incandescent bulb in your house, it will have it will emit a light, right? Then those particles that will be emitted by the fluorescent and the incandescent bulb, it will emit a particle called photon, PHOTON. Okay, this is a light particle that carries electromagnetic force that holds together the electrons. Okay, now this photon electron will reduce like this, and will react to the energy of the electrons. Okay, energy from the photon plus energy of the electrons combine, right? So if they combine with each other, then they will move with a certain position and velocity, and it will go to your eyes and to the ground, to the floor, so that you can see clearly your laptop, your mobile phone, something like that. So there's an equilibrium between the energy of the electrons, okay, and the energy of the photons as a particle. They combine with each other, okay, and there will be a excited, EXCIT, they will move. The electrons will move and something like that, and it will emit a light, something like that. Okay, get the point? So that's why we can see the, you know, the wavelength of the light you see from our eyes, something like that. Okay, now it will produce a color if it is already having a too much frequency, meaning cycles per period of the wavelength. For example, this is the light, will emit, okay, a wavelength in a certain frequency. For example, 430 times, okay, like that, per time, per second. For example, if it will emit a 430 cycles of the wavelength with corresponding position and velocity, okay, then example 435, then that would be a color red. You will found in your eyes. Then if the frequency, meaning cycles, frequency, you know, cycles of the light emitted in a wavelength, for example, is 735, like this, then the color will be violet. Okay, so if there's a frequency of the wavelength of the particle photon emitted from the light, then it will produce various colors, something like that. Okay, it depends on how much the frequency of the wavelength emitted, okay, by the particles called photon. Okay, something like that. Okay, so this is gonna be, I memorize only two, but I don't memorize the others. There's a lot. Okay, the, you know, the frequency. If the frequency is this, the color is blue. If the frequency is this, the color is white. You can see in your eyes. Before it will produce a color, it must reach this frequency. Okay, something like that. Responsible for that is the photon particles, PHOTON. Okay, so if the question will say, what is the particle emitted by a light? Your answer will be photon immediately without question. In a certain examination, something, not an electron, not a proton, not a neutron, not a positron, not a fermion, not a lepton, not a neutrino, not a what else? Tau, boson, a lot of subatomic particles. Okay, if you can memorize those and their behaviors, especially in studying quantum mechanics. Okay, something like that. Oh my gosh. So the mass of the electron, I keep this always repeating, guys, because it will be used every time in the quantum mechanics, really. Okay, so 9.11 times 10 to negative 31 kilogram. This is the mass of an electron. 9.11 times 10 to the negative 31. For example, calculate the force and the magnitude between two electrons, okay, counteracted with the photon particles like this, with a certain distance of, let's say, 1,000 miles in the universe. Oh, ganon. So you cannot compute the force and the magnitude by using this mass. Okay, and by using also the gravitational force constant of Newton, diba? Which is equal to the 6.7 times 10 to the negative 11 kilogram. Okay, Newton, sorry, meter squared kilogram. Okay, Newton squared kilogram squared. Okay, Newton meter squared kilogram squared. Okay, so in order for you will not be confused with the units, you can do the cancellation somewhere along your formula, and then if it cancels out, then That's correct. Because sometimes our memories fail, really. Okay, something like shout out, Katrina. Okay, ganon. What else? The mass of the proton. Okay, the mass of the proton. The mass of the proton is, let's see, 1.67 times 10 to the negative 27 kilogram. Okay. Like that. Okay, and the mass of the neutron is also nearly equal to the mass of the proton. That's why they are banded together inside the nucleus. Okay, and this negative 31 electrons is in the outermost shell of the nucleus, the lightest, because it has a lightest mass, the electron. Okay, it's always the electrons that will move from one orbital to another orbital, energy level to another energy level, and then the movement will be from higher energy level to lower energy level, from higher orbital to the lower orbital, because the electrons will jump orbital to orbital. Really, especially if these electrons will combine with the photon particles. Okay, something like that. Oh my gosh, now I need to introduce formulas now. Okay, so the energy of a photon formula was discovered by Max Planck, or Planck law. Planck's law is one, Planck's law, or Planck's equation. Okay, like this. Don't forget this one. Sometimes it will come out to the board examination or future examination, something like that. Okay, this is represented as E also. E, or the energy of a photon, light, meaning light, right, is equal to the h times the frequency. This is now the formula. This is the Planck's law, or Planck's equation. E is the energy of a photon, is equals to h, the Planck constant, as I mentioned a while ago, right, 6.67 times 10 to the negative 34. Okay, like that, joules second, something like that. Okay, get a point, and then times the frequency, in which it is a cycles per period, something, cycles per time, sorry, Hertzmanship. Hertz, the unit of frequency, guys, is Hertz, H-E-R-T-Z. When you talk about Hertz, there's always time in the denominator. Okay, it could be seconds, hour, minutes, but the standard is seconds, so that's my clue. So it's gonna be cycle per second, period per second, vibration per second, ganon, pag Hertz siya. Okay, like this. So we can solve now for energy, and we have also this equation. Okay, if you have like this, an orbital, something like this, circulatory, this is like this, and we have here the radius r, like this, the radius r, and if you extend that here, that will become the diameter, right? So the centripetal force in physics is equals to the mass times the velocity squared over the r. This one, centripetal force, meaning directed to the end side. That's why it's called centripetal, meaning center. So take note, the arrow is going to the center, meaning center. So centripetal force is equals to mv squared over r. Ganon. Okay, and we have also, since we know that the universe is composed of an orbit, so we need to have an equation also, which is F is equals to, okay, the Coulomb constant, like this, right? And then times Q over R squared. This one. So this one, F is equals to Coulomb constant times Q, which is the charge of one particle, and this small q is the charge also of one particle. For example, if the two particles are being considered are the same, electrons also, then it will be raised to the power 2 because the same and siya. For example, calculate the force and the magnitude between two electrons with a distance of. Calculate the force and the magnitude of between two protons with a distance of. So this is all charges. It's just written in capital U to distinguish which is the other particle and which is not. Okay, but in most of the problem solving in quantum mechanics, okay, there are two electrons considered with a distance apart. It's also very rare to say one electron and another one is proton. So it's not like that, okay, because proton and electron don't have the same behavior. Okay, the electron is a negative charge and the proton is a positive charge, something like this. Okay? Then here also we treat this in equilibrium. Okay, in equilibrium. So F, let's say this is F1 and this is F2. So F1 is equals to F2, something like that, and you can derive for the Bohr radius value and the velocity in meter per second value as what I told you here, the constant, and that we don't need to memorize. Okay, you memorize, okay, and you can also derive, but it will take time to derive. That's why I memorized already, but I know also the formula, something like that. Okay, so it's gonna be the reason. Okay, now we have this. Let's say this is equation 1. Gosh, equation 2. Okay, equation 1 and equation 2. Equation 1 and equation 2. So we let that as equal. Okay, so we have mv squared over r is equal to kc. So let's assume, guys, that this capital Q here is the same. Okay, the same part. First of all, we are considering both electrons siya. Okay, so that's small q na siya. Okay, so it's gonna be q squared, okay, over r squared. This one. Okay, equate, and then we have to solve the value. Okay, something like that. And then we can obtain a value of h over 2 pi over m dr, something like that. Okay, and then we have this value after the derivation. H is equals over 2 pi is equals to m dr, and we'll compute for the radius. Okay, or we can say also like this, r is equals to h over, okay, q squared, okay, 4 pi squared kc m, like this. Or this one also, okay, or you can use this formula also. Radius, height over this quantity for quantities here. Actually, you have to derive only with these quantities like that, okay? Knowing the fact that you have the Planck constant in this relation here, okay? Like this. Get a point? Okay, something like that. Now, we need to discuss the uncertainty principle. Actually, the uncertainty principle discovered by Werner, Heisenberg. Okay, he said that when the electrons are moving in an orbital, something like, or an energy level, so the electrons, or could it be the particles or the light particles, photon, so they are moving with different position and different momentum, something like that. So it's impossible that both of them have the same certain momentum and certain position. It could either be there's a certain position, okay, but the momentum is not certain or changeable, or it could be certain momentum or changeable, okay, position, something like that. So that's why uncertainty, it's not certain. The two quantities, momentum and position, are not certain when this electrons travels or the light particles travels. That is Heisenberg's theory of uncertainty, discovered by Werner Heisenberg. So the Werner Heisenberg formula, it's gonna be like this: delta x plus delta p, so less than or equal to h over 4 pi, this one. Delta x, delta p. Delta x is the position of an electron when it travels, or when it moves, or when it transfers from energy level to another. Okay, delta p is the momentum as the electrons travels during the movement, okay, in one energy level to another energy level, meaning the orbital. Okay, like that is this, okay, h over 4 pi. So when you compute for this, you try to eliminate this greater than. You will say just equal, like this. When you have the delta x, you solve for delta p, like that, okay? Like that. Since that is the case, they are inversely proportional with each other, the position delta x and delta p. For example, you will solve for delta p. Since that is, you know, it's gonna be like, ano siya, delta p is equals to h 4 pi, like this. Why? You remove the delta x because of Heisenberg theory of uncertainty. Okay, if the position is certain, then the delta p is changeable. So we compute the delta p is equals to h over 4 pi. So you can compute now for the momentum. Or in another way around, if the momentum is certain, okay, then you can compute to the x, the same. So delta x is equals to h over 4 pi, like this. So that's why this Heisenberg theory or principle states, okay, so the position and the momentum of the electrons as it travels on the orbital energy level is not really certain all the time, the two. One of it is certain and the other one is changeable. Okay, if the other one is changeable, then compute for that because the other is constant, is certain, meaning certain, constant. For example, this one, delta x, position, delta p, momentum, okay, like this. This is greater or equal to h, like this, over 4 pi. If you say the position x is certain, meaning constant, then you will only compute the delta p is equal to, like this. No need to carry the delta x because of the theory of Heisenberg theory of uncertainty. Okay. Also the delta x, something like that. If the momentum is certain and constant, okay, or fixed or specific, then you go directly with the delta x. Ang tango na mo siyang delta p. Kani siya, less than mo siyang equals here. So equal, so makakompute na ka kay h, we have man, h is equal to the Planck constant, okay, 6.67 times 10 to the negative 38 joules second bang yun siya. Okay, then over 4 times pi is 3.1416. So bingo, we can solve for the position, or we can solve also for the momentum. This one is measurable, meaning measurable, there's a value, and pi is 3.1416 in algebra. Okay, and 4, of course, if you multiply 4 times 3.1416, we have a value, so we can compute for delta x as easy as that, or delta p as easy as that, the same with delta x also. So the most likely question for this is gonna be like this: calculate the position of an electron if the two electrons will travel at the distance of blah blah blah, so and so, like that, with 10% certain momentum. Ganun siya, 10% certain momentum. So klaro kayo siya nga, computation of Heisenberg theory of uncertainty equation will be used. Or calculate, ganun siya, calculate the position of an electron as it travels, something like that, 20% certain position. Okay, 20% certain position. So if you have now the answer of delta x, something like that, you have to multiply only by 20%, like this. So that's 20% uncertain of the position. Okay? 10% uncertain of the momentum. Meaning kasi 0.10 times the momentum na imong nakuha siya. Something like that. Okay? Got the point? And the formula of momentum is very easy in physics. Momentum is equals to mass times velocity. Okay, like this. Just compute this momentum, mass times velocity, and the unit will be kilogram meter per second, because mass is kilogram and v is meter per second. So the unit of momentum is kilogram meter second. Okay? You get the point? Okay, like that. Okay, and then if you get the P, if the problem will state 10% momentum certain, if you obtain the P, just times it with the, or multiply it with the percent. Okay, certain, like that. That's a Heisenberg equation na talaga we will use if there's that type of question. Okay, but if it doesn't say, just go on also with this formula. And since we know that the mass, again, the mass of the proton, you know that already. The mass of the neutron, you know that already. The mass of the electron, you know that already. Then you don't have to worry. Okay, that's the point. Like, for example, calculate the momentum of the light particle photon emitted by a fluorescent bulb. Something like that. There's no given. How can you solve that one? There's no given even single data. Calculate the momentum of the light particle photon emitted by a fluorescent bulb or a fluorescent light. So, magsakit din mong ulo mo. Nakalisod sa ani ikaw, will siya given. Ano na yan? Libog din kanya, maratol lihog ka. Ganon. But actually, you can compute because the mass of an electron will be equal to the mass of the photon because they are in equilibrium with each other. Okay, the photon will give the energy to the electron, and the electron will also receive the energy of the photon. When they combine with each other, so automatically the mass of the electron will be equal to the mass of the photon. Now, the photon is the particle emitted by the light or the fluorescent. So the mass of the photon is equal to now 9.11 times 10 to the negative 31 kilogram, the same as the mass of the electrons due to the equilibrium process, the combination of its energies. Now, what is the velocity? Okay, we have also a constant of the speed of light. The speed of light, as I told you over and over again, 3.0 times 10 to the 8 meter per second. Okay, speed of light. So you can compute for the velocity or something like that. If there's a speed of light given there, then you can use. But assuming there's no velocity, then use the velocity of the speed of light, which is 3 times 10 raised to the power 8 meter per second. So even though there's no given in the problem, you can still compute what is being asked. Something like that. Okay, you get the point? Or this one, momentum, mass times velocity. And we have a lot of formula here also here. Okay, here there's a mass. Okay, and here also there's a velocity like this. Then you can compute also through this equation if you want, but assuming that is a circulatory, meaning just like in the universe, orbit of the universe. This is applicable because centripetal force, but for others it will not be applied. For example, the force is applied horizontally in going to the left. The force is applied horizontally in going to the right. This will not apply because this is centripetal force. You get the point? Okay, and this is not applying the law of inertia, the first law of Isaac Newton. Okay, the law of inertia is applicable to the horizontal. So in statistical mechanics, right, force is equal to mass times acceleration. But here, this is not statistical mechanics. This is quantum mechanics. Our basis of calculation really is to use the orbit in the universe or the Bohr model, okay, discovered by Niels Bohr, something like that. And then we can apply the Planck's law, the Planck's equation here above. Okay, and we can also use the theory of relativity equation. E is equals to mc squared. Okay, a lot. All you have to do is to analyze really if it's really valid, logical, and reliable. Then you can also feel that if the choices are there, something like that. Okay, because most of the examinations are multiple choice, especially the board examination, something like that. Okay, but for examinations that require solution, that would be a problem. But I think they will give you points also somewhere along the way. Okay, something like that. Okay, so like this one. Okay, and then okay, this is E is equals to mc squared. This is the energy. Okay, mass. C here is the velocity or the speed of light, 3 times 10 to the 8 meter per second. You can also use this formula also. Okay, for theory of relativity discovered by Albert Einstein, something. Or we have the Newton's discovery and in the universe. Wow, nakakaloka. Gravitational force. Okay, something like this. F is equals to G times mass 1 mass 2 over distance squared, something like that. This one, you can also use this one. Force is equals to the G, which is the Newton's gravitational constant, as I told you a while ago, right? 6.7 times 10 to the negative 11 Newton meter square, okay, kilogram squared. Okay, now mass 1, mass 2 over D means the diameter, because we are referring a circulatory in the universe, the orbit in which the planets rotating and revolving, something like that. But this will not apply to not circular, this F by Newton. Okay, something like this is, can be applicable any, but this is circulatory, like this, round, something like that. Okay, so meaning to say we can also equate this F to the previous equations that we have here, which are equation 1 and equation 2. Now bingo, we can have another also formula as we go along the way to derive another equation. Okay, something like that. Okay, what else? Gonna be like that, but more or less they will be considering the same. For example, the two protons move at a certain velocity with a distance of 5 meters apart with each other. It's very rare to say one electron and the other neutron travels with each. No, it's not like that. Always the same, because here it will be cancels if you use the same electron, electron, proton, proton like that. But it's seldom to use proton here, electron here. No, it's not. Okay, because if we refer the electron will go there. If we refer to proton, the proton will go there. So don't mix up, something like that. Okay, you get the point? It's gonna be like that. That's why there's a problem that I solved a while ago, right? Calculate the force and magnitude of the protons with having 5 meters distance apart. Okay, so klaro ko siya, makuha din mo siya. Okay, by using this, ganun siya. Here, makuha mo siya through. Force means magnitude, vector quantity siya. Okay, all electric forces, magnetic field, force field are all vector quantity or vector field, meaning there's a direction of the motion to be considered. Okay, the magnitude will be the unit or the force in Newton, like that. The magnitude, something like that, just like an earthquake, the magnitude of an earthquake, the direction where it goes, the earthquake, Luzon, Visayas, Mindanao, so that's the direction. Meaning to say, there's a vector quantity, something like that. Okay, because in physics there are two, right? Vector quantity and scalar quantity. Scalar quantity will never consider the direction, just like a speed. Okay, speed of an object, or speed of a car, like that, or speed of an airplane. But if we talk about velocity of an airplane, velocity of a car, velocity of whatever chuba chuchu, it has to do something with the direction where it goes. Okay, northeast, southeast, like that, east to west, north to the left, to the right, 360 degrees, like that. Okay, so that's why velocity and speed, it's different due to the direction. Okay, but the same unit, meter per second. Okay, you get the point. And then also this velocity is considering the displacement, the direction. Okay, but this speed doesn't consider the displacement, but only consider the distance. Okay, distance and displacement is not equal. You get the point? Because the displacement is considering only the initial point to the final point, even though they will go in zigzag, zigzag, zigzag like that. So it's always the final and the initial. Okay, but for the distance you have to measure everything. Zigzag, zigzag, so distance 1, distance 2, distance 3, distance 4, distance 5, distance 6. So that is your speed. Okay, so that's why velocity is equals to the displacement over time. Okay, so meter per second pa din siya. Okay, with speed, distance over time lang siya. But still, meter per second, so they have the same unit. The applicability and the usage of the problem, it depends on how you use it. Okay, so you will never say the speed of the typhoon, because the typhoon normally expressed in direction, southeast, west. So you will say the velocity of the typhoon, something like that. You got the point? Okay, but still others are using speed. It's not speed because it's velocity, because it's direction, vector, quantity. Okay, but sometimes, you know, they are just, you know, journalists. They are not really a scientist. Sometimes they don't know about the terms, scientific terms. That's why. Okay, got the point? Okay, so now before we end for this short vlog, I need to describe that there are 4 types of forces. We have the gravitational force. The gravitational force directed downward, okay, on the Earth. We have the electromagnetic force in the principle of electromagnetism and magnetism and diamagnetism. Okay, that is used in the hospitals for the laser during medication or medical operation. So it involves the theory of electromagnetism. It involves electromagnetic force, and then it goes along with the radiation. Okay, laser, light through light, it will penetrate to your organ. So light amplification, simulation, emission, radiation. So it has electromagnetic force. Okay, the other force is the weak intermolecular force. Okay, the weak intermolecular force usually expressed in gases. Okay, could it be an ideal gas or an ideal gas? And the last will be the strong intermolecular forces. Okay, that holds together the chemical reaction in a band, in a certain bonding, something like that. So could it be the hydrogen bonding? Okay, the van der Waals bonding, the ion-ion ionization bonding, the polar covalent bond, the non-polar covalent bond. Okay, something like that. If you remember that one, okay, they will unite with each other. So that is a strong intermolecular forces or strong forces. So 4 rigid siyang forces ha. Maybe it will come out in the examination, enumeration. Question number 1, what are the 4 types of forces? And you don't know. There's no choices. Your answer will be gravitational force, okay, weak force or weak intermolecular force, strong force or strong intermolecular force, and then the electromagnetic force. 4. Okay? Something. The electromagnetic force and the gravitational force are applied in quantum mechanics. But the weak and the strong intermolecular forces are applied in chemistry, physics, and unit operations, or any different sciences, reactions, or physical and chemical processes. Okay? Like that. And then the electromagnetic force, yes, applied in also in the quantum mechanics, and also in electrochemistry. Okay? And electrolysis. Okay? Magnetism. Okay? In physics, something like that. Okay? So, upat rigid siya. So, when we say, what is an applied force? Asa man na siya nabilong? So, it could either be a weak or strong. Okay? You apply a force of this force to move the object. Okay, you applied a perpendicular force, something like that, okay, or applied force. Then when you move this, for example, I move this table, then there's also another counteracting resisting force known as the friction. They will react with each other, right? So if you move, there's also a resisting force, especially if the floor is very rough. You have to consider the coefficient of friction. Ganon. Okay, so those are either weak force or strong force, but could never be gravitational force because it is horizontal, not downward. Vertical lang yun siya ang gravitational force. Okay, or in the planetary movement in the universe, what we discussed in quantum mechanics is an orbit. Diba? Dili man siya move downward, right? But they move in the orbit. Okay, so why they are not falling? Because of the gravitational force. Even though that is not directing downward, but still the gravitational force. Okay? Muna siya exemption sa downward. But here inside the Earth, always directed downward ang gravitational force, ha? Okay, that's why we have acceleration due to gravity equal to 9.81 meter per second and 32.2 feet per second squared. Acceleration man siya. O, second squared siya. Acceleration man siya. Acceleration man siya, meaning, as what I could remember, acceleration is the rate of change of velocity man siya. So, acceleration is equals to velocity over time. So, it's gonna be meter per second squared, 9.81 meter per second squared. And it's gonna be feet per second squared. Okay? Just like if you will forgot, then you can remember that one in such, like that manner. Sometimes you can forget the unit, then you can recall the definition, right? The rate of change of velocity is an acceleration. The rate of change of the displacement is the velocity. The rate of change of the distance is the speed. Ganon. The rate of change, meaning to say there's a time in the denominator always. Because the rate man siya. Just like in reaction kinetics, right? dA over dt, or time in the denominator. So that's why rate, R-A-T-E. Huwag yun na siya per me. Okay? I get a point? Nakakaloka. Okay? Something like that. Okay? Then kung flux po siya, guys, naging siya area, ha? So flux, momentum flux, na ganon siya. You get the point? Na siya yung mga, kung ba, mga inaanak siya, yung timanaan. Charot! Okay? Na pa rin mga magnetic field strength. Ang sabi formula, ang sabi unit sa magnetic field strength. Ganon. So, it's gonna be like ampere times over the meter. Ganon siya. Okay? And we have also the magnetic flux. Okay? Magnetic flux density. Wow! Nakakaloka. Gonna be like that, magnetic flux density. Okay? Ang sabi unit ano niya? So, it's gonna be kilogram per second squared meter, right? Magnetic flux density. And we have also electron density. Okay? Not only the density normal, ha, na we consider in the water, in the gas. There's also another terms of density, right? Really, electron density, magnetic flux density, ganun siya, chuba-chuchu. Okay? And then there's a formula also. For example, magnetic field strength is equal to the magnetic flux density over the magnetic permeability mu. Wow. The magnetic permeability, that's still equivalent to the coefficient of friction in the forces of Newton, right? Work is equals to force times distance, and it will become work is equals to force times cosine theta. Ganon. Work is equals to force times distance cosine theta. Cosine is ano siya? Wait. Cosine is h cosine theta. Okay? Work is equals to force h cosine theta, and then it could also work is equals to force is equals to the length. Okay? The b sine theta. Okay? The Pythagora. The law of Pythagoras theorem of right triangle, because not all the time you will apply the force directly horizontal, sometimes perpendicular in angle with angle of inclination. So that's why it matters na dili na to siyang work is equals to force times distance nga plane lang siya. You will use the work is equals to force times H cosine theta, ganun siya. Basta masabtanan mo siya katong mga Pythagora, imuro ko na buhatan, magdudruira ka, o, mukha ni kag FBD. Okay? So our stock knowledge, diba? FBD, free body diagram, is very important, and we need to take note what are the forces going here, what are the forces going counteracting, what are the forces going downward, and what are the forces going upward, and then equilibrium. And someone sets to 0 to simplify our equation. It's gonna be like that in engineering. Okay, engineering computation of different problems is always like that. Okay, it should be, you treat that in equilibrium. Okay, so that ma-simplify ragudi mo siya ang mga equations and formulas, and then you can create your own formulas and equations. Okay, thank you so much for watching this vlogging. It took me a long time because you know, I researched more, and at the same time also I had a lot of work, also a homework job inside my room because I cannot accommodate all my job in the field or in the work. Just a lot safety documentation system, it takes a lot. Okay, because we need to polish and refine our OSH program. Okay, thank you so much for watching Mercer Cabaral, Sean Christian. Okay, ganun siya. Thank you so much. Bye bye guys, everybody.